Okay, let me get my pen out. Again, we're in section 53. My expectation is you're going to read the contents, make some attempt to understand what's being presented, understand the examples. I'll go through those, and then you're going to do exercise on your own. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Algebra course. This document, the PDF at least that you're looking at now, is being made available to the Prison Math Magic Project participants only. At some point in the future, it will be published. My name is Bannon. My email address is also Bannon. That's B as in boy, ANNON.US. All right? So let's take a look. Again, I'm not going to read the content to you, but you should read through that, all right, including if you're not completely understanding what they're talking about. All right? So again, determined by inspection the nature of the roots of this problem over here. And there's many ways to do it. I'm not saying there's not just one way of doing this over here. But one thing I want to get across to you is that you do have a quadratic formula, and the roots of this quadratic equation, let me write this down for you, would be minus b, I'll talk about the b's later, plus or minus b squared minus 4ac over twice a. Well, what I notice about the a, b, and c, I'll write this down for you. So the a is going to be 2, the b is going to be minus 5, and the c is going to be minus 18. What I notice about they're all, they're integer numbers. They're super easy. What I'm worried about, though, is I'm worried about that root. All right? And what's the root going to be? Let's write this down. And this is what's known as the discriminant. The eradicand's the discriminant. So let's say, what's b squared? 25. And again, I'm doing the root. That's my big concern at this point over here. And then I got minus 4 times a times c. Well, 4 times a is 8, and 8 times 18 is 80. That's 144 now. So it's plus 144. What's nice about this is it's just simply 169, which I also know to be an integer. It's 13. So everything's an integer. Everything's an integer. So I'm going to say the nature of these roots over here is they're going to be rational. All right? So the roots are rational. That's one thing I know. Could I write the roots down? Very easily, by the way. I could write the roots down. All right? And before I do that, though, if they're rational, I'm going to say this thing's going to be really easy to factor. Let me put that down for you. So I know my roots are rational. Now, this is factorable. When I say factorable over the integers. Everything can be a nice integer. So what do you get over there? Let's take a look. Maybe, I can say 2 and 9. And let's see what you get here. I'm going to say plus and minus. So what do you get over there? 2x squared. That works beautifully, right? We're looking at this. Then you get 2x minus 9x minus 5x. Yeah, things are looking good. So what are the rational numbers? X equals, I do not need the quadratic formula to do this, by the way, minus 2, or the other one would be 9 halves. All right? So again, looking at the discriminant is really important. Why is it important? We want to make sure that that for one thing, it's going to be a positive number. In that case, we can take the root of it. It's nice to get a perfect square because then I definitely get a rational number. That's what we're looking at. All right, we're really looking at the discriminant. Now, if the discriminant is negative, I know I have complex roots. If it were not a perfect square, I know I have irrational roots. Yada yada yada. All right. So what are you going to do? You're going to work. What are you going to work on? You need to work on these exercises. Now, I want to just simply go back over Wells's text. He doesn't say much, but I'll be honest with you, for a lot of students, it's overwhelmingly complex. Give it a little bit of thought. We're not asking you to memorize, but give it a thought. Now, what I mean by giving it a thought, give it a thought about what he's writing down and what he's saying. He's really saying the same stuff that I'm saying, but he sure is wordy. Maybe you think I'm wordy too, by the way. But the bottom line is, you got to read this and make some sense of what he's saying. You really do. All right? So what I'm going to do over here, talk about the exercises. Please do work through it, each and every problem. And then it's a lot of problems, too. I'm not saying it's not. I think it's 10 problems, but you can get through that, right? And then what do? You get to the SAGE business. Very typical, right? What's SAGE? It's a computer algebra system. You've probably heard this 100 times already. What are you going to do over there? Well, maybe go to the website, pick up the software. You can either download it, interact with a web-based application, maybe do a little coding, right? See if you can learn from it. And again, typically people learn from coding by reading it and trying to make sense out of it, all right? So here's the deal. If I make an error, and I can guarantee there's an error somewhere, there's got to be. There's no way I'm error-free. I'll never be error-free, nor will this text ever be error-free. There's always going to be something wrong with the text. That's a given. That's true with any text. There's always something wrong with it. But again, if you think something wrong, you want to reach out to me, please do so. I'll try to address those deficiencies as people write to me. I have an advantage over publishers. Publishers have editors, and sometimes things are really slow to get updated. All right? But again, you want to see if you can reach out to me and let me know what's wrong, okay? Thanks again.